Okay, this is the tutorial for uPlatformer version 0.1, and the first thing we're going to do is import the package. I've got it right here, and I'm going to go ahead and import everything, the whole package. And then the first thing we're going to do is get the documentation file open, and we're going to follow along with the documentation file. So I'm going to go to uPlatformer documentation and open this up. And the first thing we're going to do is just get the initial setup. Now, if you want to look at the demos, go ahead and go into the demo scene for 2D. That is platformer 2.5D is actually what it is. It's 3D, but the camera's locked and the character's locked into the Z-axis. And then there's the 3D demo, which has 3D movement. Now I need to give it just a second to bake the lighting, but you can reference these demo scenes to see how everything is set up. But we're going to create that. We're going to create this setup from scratch. So I'm going to go ahead and go to a new scene. So let's go to a new scene, and then first of all, I'm going to need some kind of a ground, so I'm going to make a plane and put it at 0, 0, 0. And the first thing that you're really going to need is a character. So we're going to import a character. I'm going to go to the asset store. And so you're going to need to import some character. I guess I'll try Space Robot Kyle. I haven't tried this character yet, so it'll be a good example for a brand new character I've never tried. And we could go to the documentation and see that we're going to need to set it as a humanoid. So on Space Robot Kyle, when I find the actual 3D model of the character, which is right here, I can see that the animation type is set to legacy. I'm going to set it to humanoid, and the avatar definition says create from this model, so I'm going to hit apply. We can click configure, but that's going to change our scene, so it's going to ask us to save our scene. So I'll just name this test, and we could see that it has a everything's green here, so it has a Mecanim compatible skeleton, and it has its own avatar set up. I should see the avatar right here underneath of the model, and so we have it set to humanoid. And we don't need any animations. If your character has animations, that's fine. Or maybe it has a walk or a run cycle that you want to use that's specific to that character. But I'm just going to uncheck animations. We don't actually need them. And now I can drag my character into the scene. I'm going to start with him at 0, 0, 0. And checking the documentation, we need to add the PlayerController Script. So I'm going to go ahead and add the PlayerController3D Script. And now we're ready to configure the character controller. So that adds a character controller, but that by default is probably not set up right. This one's going halfway through the ground, and the values that we're going to need to use are set right here. The skin width is 0.002. Now if you want to use a little bit different value, that's fine, but a really low value for the skin width is what will work good with this pack. And the center needs to be half of the height. And so the height is 2. I'm going to try 1.8. And this needs to be half of that, so 0.9. And I can see that that goes right up to his head. If I wanted to make it a little bigger, that's fine. So if I did 1.9, then I would do 0.95. And now make sure that the character controller is right on the ground and goes to the top of the player's head. And then the radius is a little bit too big, so I'm going to bring that down. Maybe 0.3 is good. So now we have the character controller set up correctly for this character. The next thing we need to do is configure the animator, and to do that we're just going to need to make sure that we populate the controller and turn off root motion, and it's also going to need to have the correct avatar. So it already has the correct avatar set up. For the animation controller, we're going to use Player Anim Controller, and we're going to turn off Apply Root Motion. And the next thing that we're going to do is configure the bone transforms. And it needs to know, if we go to limb positions, it needs to know 3 positions: the left, the right hand, and where the top and the back of the head is at. So if we expand the skeleton transforms and we go up the hip, well, let's see, we got ribs, and then we got the shoulder, and we got the forearms and the wrist, and it looks like the wrist is actually the name of the hand, because we can see all the fingers as a child of that. So we're going to go to the left hand, and we're going to bring in left wrist, and then on the right hand, right wrist. And then for the back of the head, this is going to be one that we have to create. So first you just need to locate the head and create an empty game object there, and that needs to be at the back and top of the head. So go to the back of the head, and if you want to use orthographic view, that may help. I'm going to click orthographic here, and that gets right into the position. I'm basically lining it up with this line and this line, so that we have the position which is located at the back and the top of the head. Alright, now that should be at some, maybe not specifically Z, it depends on your character, but one of the values, basically it's the X value here. This value should be 0, so that it's right in the middle and at the back and top of the head. This one I'm going to name back of head, and of course that's the transform that gets populated right here. Alright, moving on, we have to configure the camera to follow the player. So I'm going to go to the main camera, and we're going to add CameraFollow3D. Now, CameraFollow3D needs a PlayerController3D script to follow, and we've already added that one here, of course. So I'm going to drag Robot Kyle into the player slot. And the next thing that we need to do is to add the input system. So we're going to create an empty game object and call this input system. And you may even want to have this on your game controller. So it's okay if this was named something like game controller, and then you had a different script on here that was called game controller that handles all the main logic of your game. It's okay, it doesn't have to be named input system, just some root game object that represents the main logic of your game that's independent from the player. And we're going to add into this the Unity Input Manager. Alright, so I've added the Unity Input Manager script, and this matches up all the actions: horizontal, vertical, run, crouch, jump, attack. Well, attack's not really used yet, but that matches these up to the inputs set in the input section right here. So you can see that for our run, we're going to use fire 3, and for crouch, we're going to use fire 2. So if you want to know what buttons those are mapped to, you need to go to input, and you need to look at fire 3 and fire 2. And you're going to see that fire 2 is mapped to left alt, and fire 3 is mapped to left shift. So you could create new accesses by changing the number here, and then coming down and changing the name to something like crouch, and then assign something else to this, like maybe C. And then to change that on the Unity Input Manager, you would change the access here on crouch. Instead of fire 2, we would use crouch. And that would let us use the button C to crouch. So now that we have the input system set up, we are ready to play. So I'm going to press play button in the editor, and we can see that my character is running around. Now if I were to add something into here like a cube, and let's say this cube was over here, and we want him to climb up this cube, we should be able to climb it up. And there he goes, he's climbing right up that cube. So the character controller is working, the camera's working, and now that we have a basic setup, I'm going to go over each section of the player controller and the camera script. So going back to the documentation, we're moving on to the player 3D PlayerController3D Class, and let's go through the Player Info tab. On the Info tab, there is some information here, such as the current state, whether he's standing, or you can see it change here if I jumping, falling, standing, jumping, falling, standing. So you could see this tells you exactly what state the character is in. And then for the next part, I'm going to create some slopes. So let me just rotate this out like this. And I might as well get the box over here and make this twice as big. Alright, now that I have a little bit of area to test around with, let's go ahead and hit play again. And looking at the info tab, we can see right now he says he's on the flat ground. And if I go this way, you can see it says the ground state is uphill, because it knows that he's uphill. However, if I were to face the camera, I should be on flat ground. Because in the direction that he's facing, essentially going this way, he is standing on flat ground. If he moves forward, he doesn't go up or down, and if he moves backward, he doesn't go up or down. He stays at the same exact position. So he really is on flat ground. However, if he rotates this way, now it's going to say downhill, because you can see he's facing downhill. So the ground state is doesn't necessarily tell you if the ground below you has a slope, because in this instance the ground does have a slope, but if he's sideways, it's going to say flat ground. This is the ground state for the character, and essentially if the character moves forward, is he moving forward on flat ground, or is he moving uphill, or is he moving downhill? So that's what these will tell you. And then we have a player ID. This is just set to 0, and this will be used later for multiplayer, or maybe your game has multiple characters in it that you can switch between. And then we have the raycast collision mask. By default, it's set to everything, but you can set this up to what you want, and this means that the character is not going to collide with anything that you uncheck here. So he obviously doesn't need to collide with the UI, he doesn't need to collide with transparent FX, and he doesn't need to collide with anything that's supposed to be ignoring raycast. He probably doesn't want to collide with water, because he probably wants to handle water a different way. But that's going to be something that we work later on. Water is not in this current version. So the next, so we have it set to default, and then if I were to uncheck default, you're going to see that he just goes into falling state here, because it doesn't. He's not colliding with the ground, so it doesn't know that he's standing on anything. Okay, and the next section here is debug mode. And to help show things a little bit easier, what I'm going to do is drag the game view here. Actually, I want it the other way around. Now it's all messed. There we go. That's what I'm looking for. I want the scene view here and the game view over here. That way I can kind of see what's going on in the scene, and I can also play the game over here. So debug mode shows you messages, and basically it shows you raycasts and different things in the scene here. So I'm having a hard time seeing the ground. Let me just select all my geometry, and I'm going to apply a new material to that. There's some basic colors in the materials folder under the demo section. So I'm just going to get some different colors in here so we could see a little better. And selecting him, I could have debug mode, and for one, I could see the white line here. This is just showing the forward direction of the character, whichever direction he's facing. It's drawing a line in that direction, and there's various things you can see with debug mode. But one of the really helpful one is when the character does edge grab. It determines the point of the edge grab, and it also determines the curve that he's going to climb when he climbs up. So it created a new game object here called edge grab position, and you can see that edge grab position just represents the position at which the character has performed an edge grab at. So I'm going to turn the gizmo down a little bit so it's a little smaller, but I can see right exactly the position in the world that the edge grab occurred at. Now, when I do a climb up, and I select the character, again, it's hard to see, but you can see the curve that the character is following as he climbs up. So let me jump down again and do this one more time. It's going to create a new, or it's going to move that game object to the position of the edge grab, and it's going to show you the Bezier curve that the character is going to follow as he climbs up. So he's going to go up here, and there you can see it changed a little bit, and because he's moved to this position when he climbed up. So this is debug mode. Now if I uncheck that, you're going to see that that information will not show up in the scene. So this is just helpful stuff that shows up in the scene. Okay, moving on to the next tab, we have the movement tab, and on the movement tab we have walk speed. Of course, that's how fast the character is moving when they walk. And then you have run speed, which is how fast they're moving when the run button is being pushed. And then there's turn smooth time, which is a smoothing value for turning. So if I were to put this to 0 and I try turning the character, you're going to see snaps instantly into position. So to prevent this instant snapping, you're going to want to put a smoothing value down here. By default, it's set to 0.2. And it's smooths the turns. And then we have speed smooth time, which speeds the movements. Again, you don't want the character snapping instantly to speed, so we're going to put a smoothing value in there, 0.1. So the speed changes for the character are smoothed, and this is a smoothing value for the input. So for example, with the input for the horizontal or vertical axis is between a value of 0 and 1. And on a keyboard, if you were to push the up arrow, it instantly goes from 0 to 1. And so this is a smoothing value for the input. So if I put it to 0, my input won't be smooth. It's just going to be raw input. And this will put a little bit of a smoothing value onto the values coming from the controller, whether it's a keyboard or a controller. And then there's lock Z-axis, which is going to lock the character into the Z-axis. So if you push up or down, nothing happens. In the next version, we're gonna add it so that there's an easy option. So up jumps. If you're locked into the Z-axis, up would jump and down would duck, because that seems to make pretty good sense. But we could configure that right now with our Unity Input Manager. So this locks the character into the Z-axis, and then you could change this value to what Z-axis you want the character locked into. You can see right now he's locked into 0, but if I maybe I wanted him at 5, you're going to see he locks him into 5. And if I went any farther, he would fall off the edge, but I could go -4. So this is the Z-axis where the character's locked into. And then the next section is crouching. So let's go look at crouching, and we have a let me unlock the Z-axis. And then for crouching, we have the crouch speed, which is how fast the character is going to walk when he's crouched, of course. And crouch, we had mapped to C, so now if I push the button C, he's crouching. By default, it will be on the button Alt, because that's the input Fire 3. Alright, so this is the speed I'm going when I'm crouched. And then we have static CC bounds crouching. And that means static character controller bounds while you're crouching. This normally it has dynamic character controller bounds. So if you look, you'll see the top of this is going up and down a little bit as the character moves up and down. And you'll see it a lot more significant if you jump. And you're going to notice as the character is landing on the ground, his character controller is getting smaller. I'm looking at the green capsule, and then it's getting bigger as he stands up. So if we uncheck this value, when we duck with the C button, crouch, we'll see that the character controller is still dynamic. But there was cases where, because this is moving up and down, it was bumping into the ceiling above the character. So the ceiling was right here, and as the character went up and down, this was bumping into the ceiling. So you may want to use not this dynamic bounce, but a static bounce when you're crouching. So you're going to notice as soon as I press the crouch button, it goes instantly into the crouching height, which is 0.9. And this character controller is not dynamic anymore. It's the static value of 0.9. And then I know that the character will always fit through a space that is a height of 1, because 0.9 will fit inside of that. And if you're using the dynamic character controller bounds when you're crouching, you might not fit in a spot that's 1. So that's what these two values are for. Do you want to have static bounds when you're crouching? And if so, what are the size of the bounds? And even if you're not using this, it's important still to set the height of the character controller crouching height that you want the character to be able to fit into, because that is used, this variable is used throughout the scripts for a couple different scenarios. For example, if you're climbing up a cube and you can't fit by standing there, he checks to see if he can fit into there by crouching. And the height that he uses to check that is this value. So even if you're using dynamic character controller bounds while you're crouching, you still want to set the height, because that's used when he checks if you could fit up here. And then we have the crouching head clearance. Now, crouching head clearance is for when you're crouching and then the character needs to stand up. And so what I mean by that is, here I'm going to crouch and go under. I can't fit. Alright, so here I am, and I've let go of the crouch button. But the character didn't stand up. And the reason why he didn't stand up is because, of course, he has something above him. So the script's checking to see, to make sure that if there's something above, and if there is, don't stand up yet. And then this value determines when the character can stand up. So as I move this block up, the character should be able to stand up pretty soon. There he is. And you can see that's pretty good. It's set to a pretty good value. Now if I were to change this, let me go back underneath. I'm going to crouch and walk under it. And I were to change this value and make it lower, so it was at a 1, he thinks he can stand up, he thinks he can fit there, but he can't. And now his head has gone into the block. That's no good. So we know we need to raise this value. We'll try a 1.3. And now as I move this block up, we can see I still need to make that value higher because he's still standing up too soon. So that's what that value is for. It's the amount of space that is needed for him to stand up when he's crouching. Alright, the next one is jumping. So moving on to jumping, we have a jump height, which is set to 1. So if I create a cube and I put it directly on the ground, the 0.5 for the Y position, okay, and we select him, we know it's a height of 1. So when I push the jump button, jump height is set to 1, the character controller is going to go exactly up 1. So I should just barely be able to jump up this cube. And of course, if I make 2 boxes, and I tell Robot Kyle to jump height is 2, he should be able to jump up both boxes. So you could control the exact height that you want the character to jump. And then there's a jump delay, and this one's set to 0.3 or 0.25. This depends on your animation. And what happens is when you do a jump animation like this, the character begins by ducking down or squatting down to get some momentum built up for his jump. And so now he's starting to stand up and to do his jump. And this frame is the last frame that the character controller is on the ground. After this, it should go up into the air, and a character controller should go up into the air. So there's a small delay right there when you push the jump button before the character controller is actually being pushed up into the air. And that small delay is for the ducking down animation, as we see right here. And we want him to leave the ground right now. And stepping through it slow, it's looking a little messed up on Robot Kyle, but the jump delay is exactly that. So if I push 0 here and I do a jump, you're going to see it looks funny because it's moving the character up into the air while he's supposed to be on the ground. So you can see here he still should be on the ground, and his feet should be on the ground, and he's already up in the air. So this is a delay. And if you want to figure out exactly what this value would be, you should look at your animation for your jump, and you should look at it like this and then see when the character should be leaving the ground. So I can see here, okay, his heels are just leaving, his toes are on the ground, and now he should be going up at this time. So I can see this is frame number 8. Well, most animations you need to check, but most animations are 30 frames per second. So at 30 frames per second, we can see here it's 30 FPS animation. The game is probably running at 60 FPS. So, but for the animation at 30 FPS, we need to take the 8th frame and divide that by 30 frames per second, and we get 0.26, or rounded up it would be 0.27. So basically on frame 8 at 30 frames per second, that should be 0.27 seconds. And that's why the value is set to 0.3. But to be more accurate, I could put it at 0.27. And that would make the character leave at the exact moment he's leaving the ground in the animation. Okay, so then there's double jump enabled, and that just lets you do a double jump. It's a kind of beta right now. It's not really fancy. It doesn't play animation. When you double jump, he just continues to do the falling animation. We plan to make that better, but he does do 2 jumps while he's in the air. So here I couldn't quite get up this block because it's 2. So if I do a double jump, of course I can get up there. So double jump enabled, and then the next section is falling. Falling only has 2 variables, air control percent, between 0 and 1. That's 0 and 100% control over the control of your character while they're in the air. So if I were to jump and go in the air, I just try to change my position. I'm going to try to jump to the right, and then I'm going to try to go back to the left. So here I'm going to jump right, and I can't go back left at all because it's air control percent is set to 0. Now I have full control of the character when they're in the air. So if I were to jump to the right, and then go left, I can do that. And halfway in the middle gives you half control that you would normally have on the ground while you're in the air. So I can still turn around, but it's not as quick or easy, because when your character is falling, you don't always have great control while you're in the air, but sometimes in games you want to have good control. And then there's jump, land, ray, length. This is the raycast length of the ray when you're landing a jump. And if I were to run and jump and pause it, let me do that again. If I run and jump and pause it at the right moment, well, just catch them in the air, you're going to see that by this red arrow, or this red line going down. It's a 0.5. That raycast is looking for the ground, and when it finds it, it begins to play the landing a jump animation. So right now I'm in a falling animation, and it needs to play landing a jump animation before it goes back to regular standing. And so we need to know when the character is about to touch the ground. That's what this value is for. And as we get closer to the ground, as soon as that raycast touches the ground, we should see falling transition into landing a jump, and landing a jump animation should begin to play. That would happen on the next frame or the frame after that. Probably the next frame. So there we go. The raycast has now hit the ground, and we should see the character now transition into the landing a jump. So this is the length of the ray that's detecting the ground when he's landing from a jump. And now we're going to get into edge grab. This section has a lot of variables, and it really is quite a complicated process that's going on. But it's actually real easy if we just go through it here. The character has an area where he senses an edge grab, and that is represented. It's represented by a cylinder, and that cylinder is shown in the inspector through these two round yellow circles. This is the top and this is the bottom. So you can imagine a cylinder between here that goes around all the way here, and in this area is the area that the character is detecting an edge grab. So if I were to run at this and do a jump, he will not do an edge grab right now, because it's only detecting an edge grab between these areas. So as the character falls, we're now going to notice that there's 4 red lines show up. These are the edge grab ray count set to 4. So you're going to notice 4 red ray casts. Those ray casts are going from the center of the character, or the center of the cylinder here, out to the very edge of the cylinder. And those 4 rays are looking for physics objects that the character could grab onto. And a brief explanation of what would happen. Imagine this window is geometry in the scene, and I'm going to put it right here. And so what has happened here is 2 rays have shot out. They went the full length, and they did not hit anything. The raycast did not have a hit. But now this ray came out and it hit right here. Now it knows that there's a scenario where there's some object here, but it's not up here. So there's this, it knows that there's this space right here that the character should be able to put his hands onto and potentially climb up there. And so that's what those raycasts are doing. And so the more rays I were to put in the more accurate it would be in detecting an edge. But you're going to see now I put it up to 6, so now it has 6 rays. It's going to be more accurate in detecting an edge. And you're going to notice that it's only doing these ray casts through the through this yellow cylinder area. So as soon as the character falls and one of these ray casts hits this cube, it knows there's an area that the character could potentially grab onto. And what happened there was the player stopped pressing the over button, so it stopped trying to look for that. But let's try to do this one more time. Here we go. We have the cylinder, the rays are shooting out, and the character's going to fall, and the input stopped. Here we go. I think it might... Now it quit taking input again. Oh no, it got it this time. So I think the point's getting across of what's happening here. The ray casts are shooting out if they detect an area that the character could hold on to. So if this ray gets cut short, then it knows that there's this free area up here with space, and so there's something right here that the character should be able to grab onto. I think we'll trigger that right now. There it is. You'll see that the ray hit. That triggered an edge grab point right here. This is the point where it knows that the character can grab onto. And now the character is going to grab on. Alright, that being explained, it's going to be a little bit more, it's going to make a lot more sense if I go to my edge grab tab and I see the yellow lines. We can adjust where the character does an edge grab at. So the edge grab bounds bottom, this value is the bottom of the cylinder. So if your character wasn't grabbing on low enough, you could adjust the bounds of the bottom. It probably should be, you know, somewhere around the elbow. And then the edge grab bounds top is the top of that cylinder. And that should probably be around the shoulder, or, you know, where they're going to be reaching out right in front of them. So this is the area where it's going to detect, be detecting an edge grab. Maybe we want to move that top up to the neck, or it's just going to have to be depending on our game and what seems to work good and what looks good when we're playing. So this is the whole area where it will be detecting an edge grab now, and the radius is set to 0.75. This of course is the radius of this cylinder, and as I increase it you can see the cylinder's getting bigger and smaller. This should not be larger than your character's arms stretched out. In T-pose, the character's arms go all the way. This is essentially the length of your character's arms, because outside of the cylinder the character's arms won't be able to reach to grab onto the edge. So this radius should be the length of your character's arms, and that's how far it can raycast out to detect for an edge. And then we have a minimum edge size, and it will be easiest to describe this by showing the raycasts one more time. Oops, I missed it. Okay, I'm going to use my window again to explain this. Imagine this was geometry in the world, and the raycasts are shooting out, and they hit something, and now they've detected an edge. So if that edge, it knows the size of this edge is the distance between here and here. So it knows there's this big space right here to grab onto. If this was really small, so let's say that there was just a small little bump right there, the character can't really grab onto this because it's too small. His fingers would barely, it would just barely be able to put a finger up here. So that's what this minimum edge size is. It's set to 0.2. So it says if this distance is 0.2, then just, you cannot do an edge grab there. Ignore it and just keep falling, because it's too small. So an example that might happen in would be like this, and then there's another one, and it's going like that. Well, even though the raycast detect a difference here, we really don't want him to grab onto that edge, because it's just it's too small, and he really couldn't get his fingers on that to climb up that edge. So you're gonna see that he's not grabbing on. And if we were to set the minimum edge grab size to 0, he should, yep, he sure did. He grabbed onto that edge, which is no good because he's just too small to grab onto and climb up on. That is the minimum edge grab size. And then we have the edge grab climb forward. This is how far the character climbs forward when they're doing an edge grab. And it's really easy to see this if you grab onto an edge. And at first it draws the Bezier curve from the root of the character's position, and it draws it where it's going to be moving the character up here. That goes straight onto the edge, but we want the character to move forward a little bit, so when it moves the character up and onto the edge, it actually moves them to this spot. That's what this value is. How far forward are you going to move the character? So now if I do a climb up, you're going to see that the curve has changed because it added in that value. And now you'll see that the path he actually took climbing up was to this position, because it's obviously from the yellow triangle to, or the yellow diamond to this spot is 0.25. And if I were to change that to 1, that would not be good, because the character is going to do something funny like that. And the character controller itself had trouble even making that climb. So that's how far forward the character is going to move when he climbs up an edge. And the edge grab ray count, we already covered this. This is how many rays it's using to detect an edge. So if your edge detection is not accurate enough and you want something more accurate, then you could turn up the edge grab ray count. Oh, it just flashed for 1 second. There it is. And you can see now that it's using 8 rays in between the yellow cylinder area to detect an edge. And that's will be more accurate, because again, if there was if it detects this, he's going to detect that sooner with 8 rays than he would with 4. So that's how many rays it's going to shoot to detect an edge. And then this option, static character controller bounds when climbing, is very familiar. It's the same value from the crouching. So you could see as I jump, the bounds of the character controller are actually moving up and down. And when I grab onto an edge, the character controller bounds have shrunk into the correct size. Now, when I climb up, there is potentially some problems with dynamic bounds while you're climbing up an edge. So the character controller could get stuck. So you might want to have static bounds, and I'll set that to something like 1.5. And now when I climb up an edge, instead of the green sphere here, or capsule bounds around the character, instead of that being dynamic, it's going to be completely static when I climb up. So if I press the climb up button and pause, you're going to see that these character controller bounds are completely static to a height of 1.5 as he's climbing up. And then when he gets done doing his climb up, it's going to go back to the dynamic bounds. So you'll see in this case with Robot Kyle, that didn't seem to work as good. So I'm going to go ahead and turn off the static CC bounds, and the dynamic character controller bounds for climbing up seem to work okay for this character. And then there's limb positions. We've already gone over this in the configure bone transform section, and we just need to make sure we have the left hand, right hand, and the back of head transform. And of course the back of head transform is one that we placed manually ourselves, and we created that as a child of the head. And now we have the more button, which is reserved for future section like combat. And now we're going to move on to the main camera. So coming down here, we have the CameraFollow3D Class. So let's click onto the main camera. We have a few variables here. The player that is going to follow. And then we have the focus area size. The focus area size, you can see, actually makes a yellow box in the scene. And this determines when the camera is going to move. You'll notice that Kyle can walk around inside of this box, and the camera is going to remain stationary. And anytime if he gets to the bounds, he will push that box, and that box moving will cause, of course, the camera to move. So with this little screen, I think the character is getting too close to the edge of the screen. So I could make the bounds of my box smaller. Let's go for 222. And now you can see we should adjust that not in play mode, but outside of play mode. Now you can see that he's inside of the box, and the camera responds much better now, or much quicker. So again, it's not great to adjust this in play mode. That's not going to give you probably a good accurate result. But if we adjust this outside of play mode and press play, you can see it snaps into the right position. And at any time that yellow box moves, the camera will move with it. And then we have a z-axis offset, which is how far away on the z-axis the camera is. 5, we're going to be closer. And 10, we're going to be farther away. And 20, we're going to be really far. So this is just how far away from the character the camera is. And vertical offset is how high above the character the camera is. So here we can see that the camera is higher than the character is, and if we bring that to a 0, it's going to be straight in front of the character. So we can put it to 5, and it's going to go too high. Alright, then we have look ahead distance X. That's how far ahead the camera is going to look in the X axis. So if we turn this up, it'll be easier to see. So you can see it's looking ahead now. And if I turn around this way, it's going to go ahead and look ahead in that direction. Now the look, that value is smoothed by this look smooth time. So if I turn this up to 5, you'll see that it's a real slow about making that camera movement to look ahead. And if I were to put this to 0, it's going to be much quicker, actually instantaneous. So that doesn't look any good. We're going to put it to a value of maybe 0.2. And that is for the look ahead smooth time. Now obviously a look ahead of 3 is a little far. I'm going to change it to 1. And maybe I want my smooth time set to 1 as well. And I can see now that I have a little bit smoother camera movements when I'm turning directions back and forth. And then we have the vertical smooth time. The best way to do this is to fall. You can see the camera follows the player, but it can't keep up. So if I put it at 0, it's going to stay right with the player. So this depends on how far your character is going to fall in your game and how fast you want the camera to follow the character. So if you're going to fall forever, this needs to be a really small value so that the camera could keep up. But if your character is only making small drops in the game, maybe 10, 20 units, something like this, then we could change the value so those movements are a little bit smoother with the change in a Y. So right now we have it set to 0.1. And I can see the character didn't even get close to the bottom of the screen. So if this was the maximum fall, in my entire game, I could turn the vertical smooth time up to maybe 0.5, and then the character will just get closer to the bottom of the screen there. Obviously, 0.5 was too much for that fall, but 0.3, maybe the character will get real close to the bottom of the screen. So that's what the vertical smooth time is. And that is the end of the camera variables. Next up, we're going to look at the input system. And in the beginning of this tutorial, we already changed the crouch variable to something else. So this time, we'll do a custom variable for one of the other inputs. So for the input manager, we could see here that we need to it uses a modular input system. The base class input manager has to be implemented by a complete class. In this case, we're using the Unity input manager. And there is a complete tutorial series on how this modular input system works. So if you want a detailed tutorial in depth on the input system, check out this tutorial series. But basically, we've added the Unity input manager to a game object, and we can configure these inputs in the Unity project setting input manager. So for the jump, we've set to jump. Crouch, we've set to crouch. Now run, there is not an access for that, but if we wanted a custom access for run, we could go to project settings input. There's no axis here called run, so we can make another one. We could name this run, and we could assign a positive button to that. And then if we were to go to the input system under run, now it wants the name of a Unity access. We actually have one called run now. We could type in run there. And now run is going to respond to the R button. Now, if you want to make custom actions in your game, like, let's say, lay prone or laying down, what you would do is you would go into the input folder, go into input actions. You would define a new action in the enum. And then in the input manager class, there's nothing that needs to be done there. But in your actual input manager, so Unity input manager, we would need a new string here to match for the prone axis. And this would be the name of the Unity axis. So prone, if we create our own custom axis. So if I put this in, that means that I need to go into my project settings input and create another axis here and call this one prone for P. So now I have this and then it's going to map all those into the dictionary. And when it adds actions into the dictionary, we're going to need to add our action as well. So I'm going to put add input action dot prone, and we're just going to copy how it does above with prefix underscore prone access and player actions. And so now if I want to call that action in one of my scripts, what I would do is I first just need to get access to my input manager. So that's the input manager interface, and I would call that input. And then on start, I would say input is equal to input manager dot instance. And now in update, I could say if input, so with the lowercase I, that's my input system, or the input system for our uPlatformer. So if input dot get button, and we need an integer for the player ID, that's 0, and an input action, so input action dot prone. We're going to debug dot log prone. And I've mapped that in the Unity Input Manager to P. So now I'm going to go into the game and press play. And if I press P, you can see that it's doing debug.log prone. So that is just a basic info on how to use the input system. And if you want more details on that, check the tutorial series. We will have details coming up about how to integrate with the rewired input asset. But again, it is already explained right here. So you could set that up right now. And then we're going to look at the animations and the animation controller. So there's 16 animations. And there's 14 included by default. The 2 that are missing are right here. Land a jump while you're walking and land a jump while you're running. So right now it's just playing this one for all 3 situations. And if we want to see that in the animation controller, we would just go to the Animator window, which can be accessed right here, window Animator. And if we look at the landing a jump, this is a blend tree, so I'm going to double click on it. And we can see that depending on your speed, it's going to play different animations when you're landing a jump. And right now it's just set to play this animation for all 3. We're going to hopefully add some new animations for this because it looks better if the character, when he's walking or running, as he's landing the jump, if he's moving his legs to show the running or walking. But for now, we just have the idle set to all 3, and those are the only 2 animations that are not included at this time in version 0.1. And then here is the animation controller. Just a real quick overview of what's going to happen in the game is, by default, we're going to be in locomotion, which is blend between 3 animations depending on speed. So if it's idle, it's going to be, if it's 0, it's going to be idle, and then walking and running. So depending on your speed is depending on which animation it's going to be playing down here. And then when you jump, you of course play the jumping blend tree, and the jumping blend tree again has 3 animations. Jump when you're idle, and jump when you're walking, and then jump when you're running. So depending on your speed, it will play a different jumping animation. And after you jump, you could either go directly into landing a jump if the ground was, if you jumped up onto some ground that was higher than you would directly go into landing a jump. Or you're going to go into the falling animation loop. So falling, of course, is just the the falling animation, and I'm going to pull those up right here in the animations folder. So the falling loop while you're falling through the air, and then from there you're probably going to land the jump, and landing a jump is again a blend tree. We just talked about this one, how it plays landing a jump, but you could use different animations here to make it look a little bit better, so when he lands the jump he's walking, or when he lands the jump he's running. And then it goes back into locomotion. So that's the walking, jumping, falling, landing a jump, and back to stand loop. And we can see that right now. If I do a jump, we can see we went to, let me try one more time. I pushed the jump button, so it's going to transition into the jumping animation. It's going to play that. After that, it's going to go into the falling animation. And when it gets close to the ground, it's going to play the landing on the ground animation. And then it's going to transition back into locomotion. And then we're going to see this change into the edge grab. So from falling, or from even landing a jump, we can go into the edge grab mount. So the edge grab mount plays at the moment when the character detects that he can grab onto an edge. So any moment here we should transition from falling into edge grab mount. And we won't, because you have to be pressing the input button against an edge to do the edge grab. And when I pause, I'm not pressing against with my input button. So I think it's going to trigger now. It's going to go from falling into the edge grab mount. Nope, I need to hold down the input button. There it goes. Okay, so here it's gone from falling, and now it's playing the edge grab mount animation, which of course looks like this. So back to the animator, we're going to see him transition completely into the edge grab mount, and when the edge grab mount gets done playing, it's going to transition into the edge grab idle. So edge grab idle, of course, is just sitting there hanging onto the edge, not doing too much. And when we get done with the idle, there's a couple things that are going to happen. We are either going to let go and fall to the ground, so that's going to play the dismount animation, and then it's going to transition into falling. So I'm going to do that now. I'm going to press the down arrow, and you'll see that he's played the edge grab dismount animation, and now he's going to transition back into falling. And from falling, he's going to land onto the ground, and now we're back over to locomotion. The other way we could go is that, which is climb up. So here I am at edge grab idle, and if I press in the direction of my forward, or if I push up, he's going to do a edge grab climb up. And then go back into the standing mode. And the other way he could go is this way, to the crouch locomotion. Let's say that there's 2 cubes, and he can fit there, but only by crouching, not by standing. Then when we do an edge grab, and we do an edge grab climb up, he's going to transition into the crouch locomotion. And that brings us to the last blend tree. And there's only 2 animations in this one. There's idle, which he's doing right now, and then there's walk. So, but there is no, of course, run or walk backwards. To walk backwards, you just change directions. And now we've gone from crouch back to locomotion. So that explains the entire blend tree. And if you want to use Heroic Traversal from the asset store, then come over to the asset store, find the Heroic Traversal asset, and you're going to want to import this into your project. Okay, now that I have the heroic traversal, I could grab the bandit character, bring him into the scene, and to make things easy, I'm just going to copy the player controller that we already have set up and paste that here. Of course, the character controller is going to need to be set up. I'm just going to copy and paste the values from my other one. I'm going to turn off Robot Kyle. I'm going to tell the main camera to follow Bandit. And then on the animation controller for Bandit, I'm going to turn off root motion, and I'm going to set the player anim controller heroic traversal. And then the last thing I need to do is configure these limb positions because they were set up to Robot Kyle. So I need to go to the spine under the arm and find the hand. It looks like it's this one called high-res hand because I see all the fingers are a child of that. So here's the left high-res hand and the right hand, and we need to make a back of the head transform. So I'm going to go to the head, create an empty, name it back of head, move it into position, which will be located at the back and the top of the head, and that will be assigned into that transform. And now we're ready to play. And this is set up to use heroic traversal animations. So that includes the landing a jump while you're running and landing a jump while you're walking. Heroic traversal does not come with crouching animations, so it uses the same crouching animations included with this pack. Alright, I hope this tutorial has helped you out. If so, give it a like and subscribe, and please give uPlatformer a rating on the asset store or a review. Thank you for the support. I'll see you guys in the next video.